The serial example is meant to motivate the idea behind hypothesis testing, which will be what we're exploring in Chapter 4 and also various other chapters in the course. Suppose we have a study where there are a sample of 80 4 to 6-year-old kids, and what they're asked to do is taste these two cereals. The two cereals are completely identical in terms of the cereal in the box, that they're called Healthy Bits, everything that's on the box, with one difference, which is one of the box contains cartoon penguins on it. And so what we're interested in finding out is if the children tend to actually like the cereal with the penguins better simply because of the marketing, even though it's the same cereal in the box. So the first question that we're asked here about this study is if the cartoons actually make no difference because it's really the same cereal in both boxes, how many of the 80 children would we expect to pick the cartoon box? And what sample proportion would that be? Well, if there are two boxes to pick from and they're the same cereal, then the kids should be randomly picking one of the two or have a 50% chance to pick either box if they're randomly picking. So 50% of the kids would be 40 children that we'd expect to pick each box if they don't care about the penguins. And so the sample proportion we would get then is 40 out of 80 or 0.5. So what we're really going to think of this 0.5 as being as the value that would mean that they do not care about the cartoon penguins. Now, suppose when the study was actually conducted that out of the 80 children, 52 chose the box with the cartoons. And so we have 52 choosing this box. What sample proportion would that be? Well, so we have 52 out of 80, and that gives us a sample proportion of 0.65. We said we should have around 50% if they don't care. What we actually obtained was 65%. So the question is, would that lead you to think that there's a preference toward this box with the cartoons on it? So is it that 65% could occur by chance if it's really 50-50? Or does this suggest that the children really prefer this box? So what we can do to try to get at that question, you may have a gut feeling about it already, is to do a simulation. And what we're going to ask is, if it was really 50-50 in the entire population of children, what's the chance that this sample would occur? So if we look at our sampling proportion, sampling distributions for proportion, we can set the true proportion at 50% or 0.5 for our value of our proportion. And what this is going to do when I simulate samples of size 80 is it's going to show us what we'd expect to see if we did a study with 80 kids where they really were picking 50-50 and had no preference for that box. So if I generate one at a time, we can see we got like, this one was 41 out of 80 we can see on the side, or 0.512. Generate another one, we got 43 out of 80, 40 out of 80, 41 out of 80, and so on. So these are the types of values that we would expect to see out of 80 children if the children don't care about the cartoons. So let's just generate a whole bunch of these. So we'll do 1,000 samples here. And so where is our sample value of 0.65 in this picture? We can see that if we look for our 0.65, that it's way out here in the tail. And out of the, I simulated 5 and then 1,000 more. Out of the 1,005 simulations, we can see we just have a few dots over there. So what this is telling us is that the sample value of 65% or 0.65 is not likely to occur if the kids were really picking 50-50. Okay, so if we go back to the question that we were posed in the notes here, it had asked us, does this lead you to believe there's a preference, or would you expect this sample proportion to occur by chance? And what we're seeing is that we don't get that occurring by chance. So 0.65 being far out in the tail of likely values, if the proportion is really 0.5, tells us that p hat of 0.65 is not likely if p is equal to 0.5, and that would imply to us then that we expect a value other than p equal 0.5, or that there is a preference for the cartoons. Okay, so what this is getting at is really what we're going to see is the idea behind hypothesis testing. We're hypothesizing that maybe it's 50-50. We collect our sample evidence, which was 0.65, and what we look at is, does our sample evidence go with that hypothesis of 0.5, or does it tell us something else? And in this case, a sample value of 0.65 is telling us that we probably are not going to expect to see this 50-50. What sample portions would we see if there was no preference toward the cartoons? So if we go back to our simulation and just kind of think about the middle chunk, the middle 95%, that would tell us which values we are likely to see. And so we did this with the confidence intervals, but if I just do like a two-tail here, we can see that we're expected to get values around like 0.39-ish to 0.61, but we're not expected to get anything as big as 0.65. So the answer to that last one then would be the values that we expect to see is approximately 0.39 to 0.61, not something as extreme as 0.65. So that is suggesting for us that the 0.5 as the true value is something that we would probably want to throw out as our hypothesis.